Okay, hi everyone. Today what we're doing, we are doing radicals, pretty much square roots, and we're practicing reminding ourselves what square roots are, okay? So let's see the easy one. If I just say x squared equals to 4, okay, you're trying to say what number squared is equal to 4. And the way we have learned this in Algebra 1, the way we would solve it is we would take the radical to both sides. And the idea is, this is our opposite of a square root. Sorry, a square. A square and a square root cancel each other out because a square root looks for pairs. In this case, this is looking for pairs. Pairs of numbers. So what's the pair of x squared? Well, isn't that x and x? So I do have a pair. And that gives us x. Okay. Let's do this with numbers. If I say the square root of 4, like we see here, well, that's just 2 and 2. So I do have a pair. A square root of 2 times 2 is just 2. So what pair would give me 4? Well, that's 2 and 2. 2 times 2 would give me 4. What pair would give me 9? What pair would give me 16? What pair would give me 25? So 3 times 3, 4 times 4, and 5 times 5. The square root of 16 is 4. Something you probably just had memorized. Square root of 9 is 3. Square root of 25 is 5. So it's an easy way for us to say, hey, okay, I get it. When I square something, you multiply by itself, it goes up. But when I take a square root, we go, in a sense, backwards. We're shrinking it. What number gave me 16? If I could pick one number to multiply twice by itself, that would be 4. What number could I multiply twice by itself to get 9? That would be 3. And what number, if I could multiply by itself twice to get 25, that would be 5. Okay, so easy peasy. So x here becomes plus or minus 2. Now we have a skill where we have to remember, if I do initiate a square root, it's like if you ask someone on a date, you got to make sure you pay. So if I ask this guy to be the square root on both sides, then I have to add a plus and minus here. Okay, I have to add the plus and minus. The reason why is when you square something specifically, remember, if I say 2 squared, that's 4, we know that. But if I also put negative 2 parentheses squared, right? That is also 4. So both of these could have been possibilities. So you want to catch yourself in case you miss that negative version. Is it true that x is just 2? Yeah. If I plug in 2, that would give me 4. But to solve for all the possibilities, if x was negative 2, that would also give me positive 4, because negative becomes a positive. So whenever we have an even rational, I guess you could say that, we always want to include a plus and minus. Odd doesn't follow that rule. So let's take a look at this rule. If I say a cube root, okay, this is called a cube root. And when a cube root means I'm looking for 3's, a set of 3. So of course we're going to pick the number 8, right? Because we know 8 is 2, times 2 is 4, times 2 is 8. So we do have a set of 2's. Do I have 3 of them? Yep, I have 1, 2, 3 of them. So this becomes 2. Because yes, 8 can be made up of 2 times 2 times 2. Now, if I went ahead and rewrote this, if I said x cubed is equal to 8. Okay? Because we know 2 times 2 times 2 is 8, right? So the way we undo this process is I would use radicals. And I would say, you know what, I need let's write this on my next line actually. A cube root, this little 3 means I am now looking for a set of 3. Okay, on both sides. And if you notice, I don't include no plus or minus. I don't include a plus or minus here. We said we know what the cube root of 8 is. We said that was 2 from up here. Now, do we have enough x's here? I have 1, 2, 3 x's, right? And I am looking for a set of 3. So this does come out, leaving me just x. So x is 2. Now, would negative 2 have worked here? Well, let's try 2 first. 2 cubed, is this equal to 8? All right, we're coming over here. 2 cubed is 8. Yes, 8 is equal to 8. Sure. But what if I tried negative 2? And negative 2 times negative 2 times negative 2 is negative 8. And that is not the 8 that we're looking for. So this is why we don't do plus and minus when we do negatives. So as you can see, when it's an odd exponent or an odd radical, right here, we do not include a plus and minus because that negative would not have canceled out. It would have carried through. So let me give you an example. If I say negative 2 times negative 2, if I have an even set, this becomes a positive. But if I have an odd set, this is a negative 8. So it doesn't cancel. So we don't have two options here. We only have one option. Meaning if I put a positive 2 cubed given an odd exponent, this would be positive. But if I put a negative, this would, see, this doesn't work. We said it would become a negative. So let me give you two examples real quick with bigger numbers. So if I write x to the 4th is equal to 16, or x to the 5th is equal to 32. So when we would solve these separately, we would say, hey, I'm going to go ahead and give myself a 4th root here to cancel out with the 4th exponent. I'm going to copy that to both sides. But since this is even, I need to make sure I include a plus and minus. Because even exponents get rid of that negative sign. That negative, 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 negative becomes positive. So one of our answers could be negative. On our right, I'm going to do my radical on both sides. And I'm going to use a 5 to get rid of the 5th exponent here, right? Get rid of the 5th exponent. But we do not include no plus and minus because it's odd. Because if it was negative, that negative would have shown on the other side. So this is x, right? These cancel out, becoming plus and minus 2. And this is x is 2 times 2 times 2 times 2 times 2. That's 32. 4, 8, 16, 32. So big note is we do include the plus and minus when it's even, but if it's odd, we do not. Okay, we do not. Hopefully that makes sense. Okay, let's go ahead and continue with some other stuff. Rules that we know about radicals is what if I don't have enough pairs? Say if I give you a square root of 8. Well, one way I break down numbers for radicals is I do this upside down division sign. Division usually goes this way, right? And you would write 8 there. But I write upside down. It's going to be easier for me. Usually I don't have space on top, but I do have space on the bottom. And in a typical way of you doing division, you'd write, for instance, divide by 2, and 2 becomes 4, right? 2 goes 8 4 times, and you would just write all this work. But for us, since we're trying to do this quickly, and we're not trying to spend all our time writing, we can do division as we see it. So first let's go ahead and I'm going to write the 2 in the front. And I say 2 divides into 8 how many times? Or 8 divided by 2 is 4. So write 4 on the bottom. And then I draw another division sign, and we try again. 4 can divide by the lowest number, 2, and we have 2 again. And let's double check, is it 2 times 2 times 2? That is 8? Yeah, right? So we're able to look at all the factors, all the prime factors. When we do it in this simple upside down, I call it box method, but box method has always been used for, that word box method being used in a lot of different ways. Okay, so next thing I want to say is this is a square root, right? That's a square root. And square roots are looking for pairs of 2. Pairs. So I do have a pair here. I circle it. That goes out. What's left over on the inside? I have 1, 2 left over on the inside. So you don't always come out clean with the radicals. It turns out that the square root of 8 is between the square root of 4 and the square root of 9, right? Isn't square root of 8 kind of right between there? And the square root of 4 is 2, and the square root of 9 is 3. So looking at numbers, if square root of 4 is a whole number 2, and square root of 9 is a whole number 3, can the square root of 8 be a whole number or a decimal? It's going to be a decimal, right? Because square root of 8 is somewhere stuck between square root of 4 and square root of 9. Thank you. It's going to be a decimal. So it's going to be 2 point something. And without calculator, that's really kind of what we're stuck with right now. There are ways of calculating what that square root would be to several decimal points, but why bother? You have a calculator for that. But at least without a calculator, you know it's 2 point something. So let's go give you guys another example. If I say, what is the cube root of 32? Okay, cube root of 32. So I'm going to draw my upside down. Some of you guys have learned it using this like tree branch method where you break it up and say, oh, this is 16 and 2. Oh, this is 8 and 2. Oh, this is 4 and 4. And then you break it up even more and say, this is 2, 2, 2, 2. But then the problem is, if you guys ever try to pick up leaves in the fall, you have to go up and you have to pick up all your leaves. Okay, this is a 2, this is a 2, this is a 2, this is a 2, this is, and these ending blocks are what the value is made up of. And this is fine, and if you like this, it's fine. But I always find this kind of messy with large numbers. So for me, I'm going to do this with my little box method. 2 goes into 32 using my smallest numbers. The reason why I choose the smallest numbers is because all the small numbers will be next to each other. If I see 2, 2, 2, 2, 2, they'll always be next to each other, and I won't be surprised by another 2 later. 2 goes into 32. Now, here's the cool part, is I can actually divide right on the spot. 2 goes into 3 how many times? Once. Remainder 1, right? 2 goes into 3 once, remainder 1. I put the 1 on top. Now I actually don't have a 2, I have a 12. And 2 goes into 12 6 times. Okay. Then I say, hey, 16, I can divide 16 by 2. I can divide 8 by 2. I can divide 4 by 2. And you can see now it's super organized. I can see all my numbers. 2 times 2 times 2 times 2 times 2. Okay. If you want to crawl back up, 2 times 2 is 4. Then 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. If you want to just double check. Now, this really helps me because I'm asking myself, I'm looking for sets of 3. This little cube here, cube root, I'm looking for sets of 3, and I do have a set of 3. 1, 2, 3. So that leads me to say, hey, you guys are all 1, 2, right? That's just 1, 2. So that's a 2 on the outside, but what's left over? I still have 2 2's left over. Go ahead and multiply them together, and it's 2 square root of 4, cube root of 4, sorry. Don't forget to write the little exponent for the radical. Okay. So you can practice that using that box method. It's pretty easy, just writing the division. Especially when it gets to large numbers, dividing as we see it is super helpful. Now, we can write radicals in different ways. So what about when I see it in fraction form? And one of the rules that you learn from Algebra 1 is that the square root of, let's say, 5 over the square root of 6, okay, is just the square root of 5 over 6. You can write them in a square root or out of a square root. You can go back and forth as much as you want, as long as the top stays on top and the bottom stays on bottom. Now, this might be helpful if you're trying to simplify a problem, right? What if you're doing something like the square root of 3 over, oops, oh yeah, over 27. Okay. Well, you could get this as, hey, does a 3 divide 27? It does. So you end up with 1 over 9, because 3 times 9 is 27, and the 3's will cancel out. So you still have a 1 on top, so be careful. Now, you can split this to say, hey, what's the square root of 1 and what's the square root of 9? Now you don't have to write this, and you can just do this straight in your head. The square root of 1 is 1 and the square root of 9 is 3. If you got the same problem and you got it this way, written out as square root of 3 over 27, you just dividing it actually isn't really what the rule represents. The rule represents that, hey, you can first write them together. Oh, now I can divide them. And then we end up with 1 over 9, which then can be 1 over 3. Okay, so that means we can write them together, write them apart. So that here is the goal, is that when you take radicals, the top and the bottom are separate. You take the radical of the top, take the radical of the bottom. You can simplify them if you want to bring them together, but they are still, we do them separately. So square root of 4 over 25 is really, you don't have to write this step, but it's really the square root of 4 and the square root of 27. Sorry, 25, I'm sorry. Which is just 2 over 5. You could jump from here to here, and that is 100% great. But just for your brain's sake, you can separate that. To make the problem look even worse, if I write x squared plus 6x plus 9 and x squared plus 4x plus 4, this looks a little bit weird. But if you remember factoring x squared, and these are both special types of factors, what number is multiplied to become 3? Oh, sorry, 9 is 3. And 3 plus 3 is 6. This was actually x plus 3 squared. On the bottom, 4 is 2. 2 times 2 is 4. 2 plus 2 is 4. X plus 2 squared. And this is, since I do have a square for both of them, right? A square. We do have a pair. We can get them out of a square root. So this also works for variables. As long as you have a square, a pair of them, you can take them out of the square root. Now, what about numbers that we for sure are not nice numbers? Like again, we said like the square root of 8, right? So let's say we want to find that on a calculator. So on your calculator, you have everyone's calculator is a little different, but there's a couple of different ways of doing square roots, and the easy way is just writing, right? It's just writing on your calculator. You have a square root button. So depending on the type of calculator, if you have a fancy calculator, you of course are just going to hit that square root button first, and then you're going to hit 8, and then hit equals. But if you have something like I do using this iPad here, a cheap version of it, let's see, it's going to show me an ad. Oh, it didn't. Okay. So you can see, oh, it done. Knew it. So you can see that I have a square root button right there. So for me, if I just hit square root all day long, it's not going to work. So on these types of calculators, you have to hit the button, the number first, 8. So the calculus sees I'm dealing with 8, and then take the square root of 8. So you hit the number first, and then you hit the operation you want to do on it, which is the square root. And you can see here, I also can do cubes. And I can do this x to the y function. Now that one's a little hard to use. And what you want to do is you want to test your calculator to see how does that function work. And if you haven't used it in a little bit, sorry. All right, so you might want to try this out on your calculator because you're not sure which way it's going to work. But if I'm trying to use this button over here, let's go and look at a problem in which I might have to use it. So if I give you the fourth root of 16, and hopefully you know what the fourth root of 16 is. 16 is 2 times 2 times 2 times 2. So the answer, since we have 4 of them, should be 2. So that's how your calculator should come out. Now, let's go ahead and jump to my calculator here. So if we follow the pattern that we used before, I'm going to write 16 first. Then I'm going, let me clear this. I'm going to hit 16 first. Then I'm going to hit this root button. And then I have to tell the calculator which root I want. I want my fourth root. Hit equals, and that gives me the 2 I wanted. Let me do this again. I write the number first. I say this is a variable root. I'm going to choose which root I want. And then I'm going to hit the root value, which is 4. Hit equals, and that gives me the 2 I wanted. Okay, so please practice on your calculator to make sure you are kind of familiar with how your calculator works. Because every calculator is a little different. There's really only like 3 ways of doing it. Okay, so you guys are going to practice that on your calculator to make sure you're in kind of good shape. So you'll do an Excel problem on that. And the last one is, what if I throw in some variables? And we've already done this simply with x squared. If I write the square root of x squared, we say, hey, that's x, right? And let's talk about why this is because I'm looking for pairs, and I do have a pair. I have a pair of x's. What if I wrote the square root of x cubed? I have 1, 2, 3 x's here. But square roots only take out pairs. So I get a pair that comes out, and x is still stuck inside. It's almost like a date night on Fridays before COVID, right? You have a pair, you get to go out, yay, they're on a date, freedom! And you're stuck at home. It's okay. Stay at home, save money. If I made this fifth root of x to the 10, okay, now I'm looking for sets of 5. Well, I do have sets of 5. So I have 2 sets of 5. So this is x squared. Now, why is that x squared? Let's write out the long way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have 10, right? So this set comes out to become an x. And this one here comes out to be another x, which gives me x squared. Because the goal is I'm looking for a set of 5. If you have a set of 5, you can come out. Well, fine. I have a set of 5 once, and I have a set of 5 twice. So this could be slightly confusing because we went from 10 to 2, but that's what radicals do. They take out not really the exponent, they take out the type, the set. Let's do this again. If I say x to the 50, and I'm going to take out 10. So how many sets of 10 do we have? Well, we have 1, 2, 3, 4, 5, right? That's 50, right? 10, 20, 30, 40, 50. And each of you guys get to come out with 1x. And that's x to the 5. Because each of these came out with 1x each. Because remember, we're counting by 5s. It's almost, let's think of it as quarters, right? If I have 40 quarters, and aren't quarters counted by 4s? How many dollars do we have? We have $10. Right. If you have 40 quarters, how many dollars do you have? You have $10. Because I'm counting by sets of 4. Okay. What about if we mix it with numbers? Let's do 32, and we'll do x to the 5, and we're going to ask for sets of 3. Okay, so let's see. In this case, I'm looking for sets of 3. 32, I don't know, no clue. Let's break down 32. 32, using my box method, 2 goes into 32 16 times. 2 goes into 16 8 times. We can break down 8, right? 2, it becomes 4. We can break down 4, 2 and 2. And what are we taking? We're looking for pairs of 3. So I'm going to circle. If you take a look here, I'm just going to circle it so it's kind of obvious. I used up 3 of them. So yes, we have one set of 2 that comes out. but we also have two 2's left, so that's going to multiply back to 4. I have 1, 2, 3, 4, 5 x's. I'm looking for sets of 3. Great, we took out one set of x's out, but I still have 2 left. Okay. So the radical says how many sets we're looking for. So if you have a set, you get to come out. If not, you're stuck inside. And as you can see, I have two 2's left over. That's why we have a 4. And I have 2 x's here, and that's why we have a x squared. Let's do one more, and then we'll call it a day. X, let's just go to the 5th power. I want to do something like 128, and x to the, let's do 7, and y to the 4th. Okay? Throwing a couple extra things here. Let's do the number first, 128. 2, 64, 2, 32, 2 becomes 16, 2 becomes 8, 2 becomes 4, 2, and 2. Okay, don't forget to, so I'm not going to box the last one because I can't divide 2 except by itself. So we can't break down 2 anymore. I'm looking for 5. 1, 2, 3, 4, 5. So I circle it so it's obvious I've used them up. You get kicked out. How many do we have left over? We still have 2 times 2 left, that's 4. X to the 7, 1, 2, 3, 4, 5, 6, 7. Please don't start writing it out. This is just for you guys to see. It's a waste of time if you write it out here for the x's. I have 5 of them. Great, you get to come out once. I still have 2 left over. How about the y's? 1, 2, 3, 4. I needed 5. There are not enough to come out, so you guys are all stuck inside. Maybe next week. Okay, so that's our reminder and introduction back to radicals. And that's what you'll be practicing for Excel today. Oh, thank you.